I hope you guys are back to the campus now.
No, sir.
Okay, planning to come back?
Sir, maybe in March, sir.
Okay, after mid-sem?
Sir, not particularly for mid-sem, but I am thinking to come in March only.
Okay. I was saying that in the last class, due to some technical errors, I could not finish that particular topic. So today we are going to start it and finish it because that's something which is very important in this course, and that's something which is very interesting. I mean, it's because it's practical. It's like used broadly, and I'll take some case studies also to explain you that particular part. Yeah, let me share my entire screen. So previously we had a talk on some basic topics, right? What basically is software architecture, some of the definitions, and then we went into a little depth of what actually is happening in this thing and how various stakeholders are involved who are taking some calls, who are taking some decisions, and so on and so forth, and what basically is the outcome, what basically is the output, and what basically are the expectations from the clients, and what the architect delivers, what the developers get, all those things we saw. Then we saw some pre-architecture life cycle. Then we thought of adding the architecture. Then we thought of adding architecture in the optimum way. Then we saw some of the architectures which I gave you actually a huge list, right? And then we took some of uh, the examples from the important ones, I would say. And in today's class, we are going to talk about 4 plus 1 view architecture, which is something which is very popular, I would say. And this is basically a model which is used for describing the architecture of any software intensive system, right? And why it is popular? Because it's based on multiple concurrent views, right? I have so what we're trying to do in the last class, I was trying to explain you with the help of the stylus and other stuff. So to save our time, what I've done is I've added the designs this time. So some of the diagrams I've added, some of the things I'll be explaining with the help of uh, the stylus and other stuff. So the good part is I have like multiple views. I'm getting everyone's perspective. All the stakeholders are you know considered, and we come up with a common architecture. Plus, if you go through the paper, right? So this is the title of the paper: Architectural Blueprints, the 4 plus 1 view, a model of software architecture. This is from IEEE Software 1995, given by Philip Crichton. Philip was previously with Rational Rose, and then these days I think he's a professor in some university. And then I'll explain you why this became very popular, plus why this was accepted largely, right? So those things we'll have a discussion in our next few slides. And yeah, I was about to uh, share a point about 4 plus 1 view which I missed. Um but anyways, so what we have is that it's like based on like multiple views and everyone's perspective, we get the viewpoint of all the stakeholders, right? So if I'm able to get the inputs from everyone, obviously the quality of the application which we are going to get will be high, right? Because I have like end users viewpoint, right? I have developers viewpoint, I have your system engineers viewpoint, then I have like project managers viewpoint. So majorly I have considered the inputs from everyone. Everyone means all the stakeholders, all the major stakeholders. So in that case, definitely it is going to yield a very good application, right? So anyways, yeah, now I am able to recall uh, what I was about to discuss. So this particular research paper, it's available on internet, right? Even from your home you can access. If suppose you don't have IEEE login, then you can get from the library, or even it is available on archive, right? So that particular thing is also there, and plus on top of it I'll be sharing these slides. And by the way, any idea about what basically this archive is? Archive.org is the website. Any idea?
No, sir.
Yeah, no worries. I thought some people will search and will give me the answer, but I'm happy that I got an honest answer. So basically, it's a free distribution service and provided by Cornell University. So what people do is that they uh, keep their research work uploaded on this particular platform, right? Which is archive.org. It's a kind of preprint of thing, right? So if suppose you want to make your things available, right? Most of the very popular papers on deep learning, you'll find that those papers are there on archive. They People never thought of publishing it with some publishers, right? That kind of thing is there. So this paper, along with the this IEEE folder, it's also available. Sorry, IEEE portal. It's also available on your archive website. So you can go through it. It's a very interesting uh, paper. But okay, so coming back to this, what we were saying was that here we are talking about all these stakeholders, right? That's what is a major thing which makes this thing popular. So Philip basically proposed a model which has 5 views, and in which one is your logical view, another one is your process view, another one is your physical view, and then we have a deployment view, and the last one is plus oneth view, right? So that is nothing but your scenarios or use case view. In case of logical view, your logical view will basically be concerned with the functionality that your system provides to the end user. So your UML diagrams are used. Then we have like process view. So your process will deal with the dynamic aspects of the system. So that would explain basically the systems, the processes, and how they communicate. Sorry, and focuses on uh, on the runtime behavior of the system. So the process view addresses your concurrency, distribution, integration, performance, and scalability. And once again, you can have your UML UCAD diagrams. Then we have like development view. So that would illustrate your programmer's perspective. That would talk about your software management. That would talk about basically the implementation, right? So this you can also call it as your implementation view. I've added those points, so no need to make jot down these things because I've added these things in the next slides. Then we have your physical view. So it's the deployment view, right? So basically it depicts the system from a system engineer's point of view. That would be considered can be considering your topology, right? Topology of the software components and physical layers if required, your physical connections between these components. So once again, we'll have a deployment diagrams. Then the scenarios are nothing but your use case views, which you've already done your software engineering classes, and this gives a generic. If you talk about all these things, 4 plus 1 view, it will be giving you a generic and which is not restricted to any notation or uh, tools or designs. So that's something which is you know which is making it very popular. And then we have this particular thing where on one side I have the logical view where I logically decompose the system. Then I have the development view, and where you have programmers and software managers. I have a process view where system engineers and other stuff will sorry your integrators will be taking care of. In case of your physical view, I have your the software components and the underlying infrastructure that would be a part of it, which is your system engineers will be paying. And then we have a scenario. Now, uh, your 4 plus 1 view will have a logical view, that is your object model of the design. And then what we have is we have like process view that would capture the concurrency and the synchronization aspects of the design. Then we have your physical view that would describe the mapping of software onto hardwares, and that would reflect its distributed aspects. Then we have your development view, which will be describing the static organization of the software in its development. And lastly, we have scenarios, the 4 plus 1 view, which is your decisions made and your description of the architectures. So this is basically the detail about your 4 plus 1 view. Let's take some examples. Let's take a step ahead to understand it. So what it has is your logical view will be talking about the decomposition. So whenever I'm talking about logical view, it's nothing but a logical decomposition of the entire system, in which what we'll get is of the system into the constituent modules. So all the possible constituent modules will be you know a part of this logical view. In case of process view, it will capture the execution time components and how they interact. Then we have like physical view, where we'll be describing the relationship between the software components and the hardware. In case of your development view, we'll be dealing with the development time issues like files. We'll be talking about people and so on and so on. Then we have scenarios, right? So we'll talk about decisions made. We'll talk about illustrations. Sorry, and we'll talk about the description of the entire architecture, right? So when we are talking about your uh, architecture, right, let me get some free space. So what we deal with is that your software architecture will be basically this kind of definition is given by your Barry Boehm. Boehm has also played a very important role in case of your software engineering. So we have like elements, then we have some rationales, and we can call it as constraints as well, right? So basically, your software architecture will be dealing with the design and implementation of some high-level structure of the software, and that would be resulting into the assembling of certain number of architectural elements that will be well chosen from form of satisfying the major functionality and your performance requirements. So what we have is that in this case, in case of logical view, I have the object oriented decomposition, right? As I said, logical view, logical relate with the term of with the logical decomposition, where well have the viewer will be services to the users, right? And see, at this moment of time, this is sounding a bit theoretical, but frankly speaking, when we'll see the examples, you'll be able to identify what kind of questions one can ask from this particular topic, and what kind of case studies you can expect from uh, this particular architecture. So the notation is like your same Booch notation of your where we'll be representing the objects and the dynamic models. And then we can use some tools where we can have your rational rows. How many of you are familiar with rational rows? How many of you are familiar with rational rows? RSA tool. No idea. I hope you people are here with me.
Sir, actually, we have listened this term first time.
Okay, okay, okay. Fine. So, uh, what tools you were using for your UML diagrams?
Sir, we were only using online softwares like online web tools
Okay,
where
okay,
we can design UML
okay. So
diagrams.
basically, rational rows is you can say your object-oriented unified modeling language, software design tool, which is like intended for your visual modeling. And you can just like your star UML, you might have used star UML, I guess. Star UML, yes or no? No? Okay, so I'm giving you some very important, input for that can be very handy for any of the other courses where you have to draw the diagrams. Star UML can be a handy one, or else another one is your diagrams dot net. Okay, these days, yes, I forgot. These days, diagrams dot net is called as draw.io. Must have heard this for sure. No? Yeah, Satvik, yes. So you type draw.io, it will take to your apps.diagrams.net, or sometimes draw.io will work. That this is, I find, the simplest, easiest one for any of the possible diagrams. You can save it in multiple format, including your let's say PNG, then other formats plus PDF and other stuff. So based on what kind of need you have, for us, it's like if suppose we are writing a research article using LaTeX. So what we prefer is we prefer to have PDF format because that helps in resizing and resizing of it. And overall, it's a very simple user interface. I would advise all of you, if suppose you need to draw something, you can visit this particular website, you can note it down. Of course, I'll be sharing the slides and with this notations, right, inked items plus the videos as well, so you can have a look on this. So this was about rational rows, again a tool. And yeah, another question: what is this OMT? You have to brush up your software engineering concepts thoroughly. What is OMT? Now I hope this sounds familiar to you guys. This term sounds familiar or no? Still no.
Sir, I think it's related to some object oriented development thing.
Correct, 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 correct. Modeling technique is basically, it's a modeling approach for software modeling and design. And the idea was for object, you might have done this object oriented analysis and design, right? There was a very popular book by James Lombok. Must have covered in your advanced Java course, which is, I think these days it's called as your advanced programming. In fact, this book, this James Rombach was the person who gave this object-oriented analysis and design, and this OAD book is very popular, right? So the modeling technique was given by James Rombach. OAD is something which is the name of the book. So, anyways, what we have is in that we get object model, dynamic model, then we have like functional model. We do some analysis, we do some system design. So those things are there, and these things are interrelated. These things should be there on your tips now. Soon you'll be in corporate where you'll be developing some software applications and these things, your design patterns, which we'll be covering, right? That's something which is very interesting. Yeah, I forgot to mention design pattern is something which is very interesting. That part is also to be taken care of. That thing is also very very uh, prominently used. Okay, coming back to this. So this was like extra things which we talked about. Some of the topics right now. Coming back to the same discussion. So we have your logical view. Then we have your process view. So that's the process decomposition. Previously it was logical decomposition. This time it is process decomposition. So we have like integrators. What we consider, obviously, we'll be considering your non-functional requirements. We'll talk about concurrency. We'll talk about performance. We'll talk about scalability, and then we can have several styles that would fit in this view. So your Garland and Shaw's architectural style is one of the possible options, and with the help of some of the examples, we'll take a look at this as well. So what we do is we use like multiple levels of abstraction. A logical network of processes at the highest level is one of the things, and a process is like grouping of tasks that will be forming some executable units, such as your architectural level tasks or maybe some helper level tasks, which can be simple buffering kind of thing. And then we have your development view where uh, we have like subsystem decomposition, that is a basis of a line of product. So where we have like viewer, so programmers and the software managers will be viewers, will be considering your software module organization. That means the hierarchy of levels, so the software management, the reuse constraints of tools, and we can have a layered style of architecture in this, and possibly we can go ahead with Booch notation once again. And then we have the physical view, and that's something which is, we said, that will be for the system engineers. So we'll be mapping the softwares to the hardware, that is what all applications will be running on what all machines. That's a simple way to explain this particular part. So that's how we deal with your physical view, and we'll be considering some non-functional requirements, and regarding to underlying hardwares, that would be your topology, the communications, all these things will be considered. And we can have several forms, and we can tightly connect the process view on this. We can have like test and deployment, or the deployment as well. So we have certain advantages of this. See, if you go through the paper, right, they have given certain notations as well. But as I said, this is something which is very flexible in nature. So we'll not tightly restrict to that particular notation as well, but yes, we'll be considerate in using some of the things. So multiple views will be addressing the concerns of all the stakeholders. That is something which is a major advantage of this. Then we'll have like multiple architectural style will be in one system, and this, with the example, you will see that this is something which is a very generic model, right? So in this, let me explain you with the help of a case study, right? Any possible thing coming to your mind? Any possible thing which to which you people are also familiar? Any input from your end? See, as far as case studies are concerned, we can have multiple cases studies, multiple possible case studies. Okay, Linux subsystem. Everyone is familiar with the Linux,
Yes, sir.
right? Possible subsystems of it?
Sir, distros, distributions.
No, no, subsystems of Linux environment. Like we have process scheduler. What is the role of process scheduler?
Sir, it schedule processes according
Yeah,
to
yeah.
their requirement.
It's basically responsible for supporting some multitasking, and it decides basically which user will execute which process. And then we have your memory management. What's the role of memory management?
Sir, it gives memory to the processes or applications according to their requirements.
Right, right. So basically providing a separate memory space for all sorts of users, or each user, right? Any other component?
Sir, storage management.
Okay, yeah. So file systems, right? Or storage management can also be. This will be responsible for this. Any other network interface? Uh, or let me. Or I think many of you are not that much familiar of Linux. So what we can have is we can have. Okay, let me take another example. That would be familiar to everyone. Right? So what we have is let's take one LMS, right? What is LMS, by the way? What is LMS?
Sir, I think it's a management system, some kind of.
Yeah, yeah. So we have learning management system, right? Or maybe a Moodle kind of thing. Or let's take very specific library management system, right? Now everyone is familiar with the library processes. Yes or no?
Yes, sir.
Right. We take some steps. What all processes are there in library management system?
Sir, like issuing a book, returning a book, these type of processes.
Right, right, very correct. Now, so we'll be taking this case study, right? I hope everyone is with me. This can be, one of the simplest possible and the easiest case study where everyone can relate to all the processes which are happening, right? Yes or no?
Yes, sir.
Except Rahul, I am not getting any, convincing answers from anyone else. Okay, okay. Then we'll go ahead with this, right? And before that, let's take one example because I need to explain the difference between your process view and your logical view. Because then only we can take one example, right? Let's take one example of mm, let's say I have a program, right? And consider this program as P and take it as a system, right? And what it does is that this system takes a string as an input. right? Further, this system P or a program P is taking a string as an input, and what it is doing is let's say it is taking Jaipur as an input, and as an output it is giving an string in a form of alphabetical order where first will be capital, another one will be small. That means this will get this Jaipur as J capital, A small, I capital, P small, U capital, R small. Right. So that's the purpose of this particular product P. Right. See, forget about library management system. I'm trying to explain you the process and logical view. Then once again we'll move back to your library management system. In order to explain these two things, I'm taking this product as an example. Till now you are with me?
Yes, sir.
Okay. So what this process view says is I am getting this string as an input, then I have a split module. I have a split module, and I'm sending first to a module which is converting the alphabet to upper, and the second one I'm sending to a module which is converting it to lower, irrespective of in what form it is, right? Whether if it is in lower, so it will be in the lower format. And then I have another module which will be merging it and sorry will be giving the output, right? That's how it works,
Yes, sir.
right? So what we have done is we have identified the process for this particular thing, right? We have identified the process for this particular thing. Now we got to know that we will be using this, 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 and this. So my logical component will be something like this. Let me draw it here only. P is your main system, right? So we have your main, or call it P as well. Why to get confused, right? Call it P, and then we have one split module. We have one, right? This one we have this two upper module. We have a two lower, and the last one is your merge. So we have logically decomposed this system P into these four modules, and this becomes your logical view. Clear?
Yes, sir.
Right. See, I am trying to explain this process view and your logical view with the help of a simple single example. Right. And the idea behind this, because it's a simple program, right? A single function will 10 15 line of code will serve our purpose, but the idea behind this is to give you a feel of what basically the logical decomposition is and what basically the process is. So basically logically we are decomposing the entire system into multiple parts, and in case of process view we are showing the interaction of these logically decomposed system sorry components. Getting my point?
Yes, sir.
Yeah. So this was about your logical and physical view. Now let's take the same case study which we were trying to focus, which is sorry your LMS, which is your library management system. Now, in this library management system, the possible components we can have will be uh, we can have one catalog module, right? We can have one catalog module that would have, let's say, the details of what all books the library has, right? Then we can have a user registration module, right? That would have the details about the users which are registered, and let's say some incoming users, then some people which are now not, let's say, not the part of the library system, so those things will be removed. So I'll have a user registration, and any new user can register it. Then we can have one, let's say, circulation module, right? So circulation module will basically give us the idea that what all books we have, what all books we have issued, and what all books we are left with, right? And uh, which book is issued, or how many books a particular user has, what all books a particular user has. So those things will be in the circulation module, right? Or or we can also have, let's say, mhm. I hope I'm audible because my system got stuck.
Yes, sir, you are audible.
Okay, okay, fine, fine. No, this thing is not. Oh, yeah, yeah, yeah. Probably it. Yeah, fine. Luckily, yeah. So then we can have. Sorry. Then we can have your journal subscription. Journal subscription module, because this will have, let's say, all the journals which are subscribed by the library, which are available for the users, right? For like every department, they'll have, some people will have IEEE requirements, some people will have, let's say, uh, ACM's requirement. Some people will say that we need the Springer's directory. Some people will say that they need Elsewhere's directory or the entire web of science and other stuff. So that kind of thing will be there. That would be a part of your general subscription. And any other module which we can have in library?
So we can have something like payment module if the book is not returned in time.
Right. Right. We can have. Oh, we can have a payment module. Yes. Any other?
Sir, employee details.
Employee can be a part of payroll, and then we have a user registration there. We can have a flag that would tell. We can have definitely, but if suppose I have, let's say, university MIS, then employee detail will make some sense. Or else under the user registration, I can have a librarian, assistant librarian, and some supporting staff, and so on and so forth.
Okay,
I
sir.
can I can have an acquisition module. Let's say means what all things the library is acquiring. Right. So these are, let's say, 6 modules. Now, let's draw the entire 4 plus 1 view architecture for this setup. Fine. Let's draw the entire 4 plus 1 view architecture for this setup. So to start with, what we have is we have logical view. That is something which is very simple, right? Because we know we have identified the modules, right? And we have like catalog, we have user registration, we have circulation, we have journal subscription, we have payment module, we have acquisition module. So in this case, uh, I need some space, so I'm erasing these things, right? You can. Oh, I'll not be able to erase this because this got saved. So anyways, I'll draw it from here. uh, Now some of you have to remind me what we had in in the last 3 uh, modules. So your logical view will look like this is LMS. On one side I have your catalog, I have your user registration, I have your circulation, then I had your journal subscription, then I had your acquisition, and what else?
So payment.
Yeah, sorry, important one. Yeah, payment, dealing with finances. Yeah. Now this becomes your logical view. Right, simple one. Identifying and then coming up with this. Right, a very simple one. Any doubts?
So we have to go up to this one level only. We do not have to go further.
No, 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 no. Because further level that would be plus one as view will be added. Right,
Yes, sir.
that part will be added. Now, next is your process view. Right, now we'll talk about your process view. So what we had catalog, we had circulation, we had user registration, we had payment, then we had journal subscription, then we had your acquisition, right? So these were some of the modules, right? If let me correct me if I have missed something here, or it's all
Sir,
correct.
these are only.
Okay, right. So my circulation module will always be in touch with catalog because that would give me an idea that what all things are available, and this circulation module will also be in touch with your user registration because this will have the details of the books issued to the users, and with the help of this catalog will display the available books, right? The availability will be displayed with this. Along with this, catalog will be also connected with your payment module, and your journal subscription will be connected to the catalog because this catalog will also display the journals which the library is has subscribed. This will also be in touch with acquisition module because what all things are acquired that would be a part of your catalog, right? Let's say today I thought of acquiring the National Geographic book for a year, so that would be a part of the catalog. This payment module will also be in touch with your user registration because each user will have some, let's say, a fine is imposed or has made some, let's say, donation, so that kind of thing will be also added. So these modules interacting with these modules, sometimes you will identify they can we can have some external agents, that is always permissible, right? At this moment of time for this we don't need, so this kind of setup we can have in case of your process view. Any doubts in this? Simple one. See, I am trying to explain it in the simplest possible way. When you'll go through the paper you'll find that okay, that is taking too much time, and it becomes, some of the topics becomes very tough to digest even.
So why we have not connected like rest of the things,
Mm, with
like
what all-
acquisition with payment, because we have to do payment when we have to acquire something.
okay, yeah. Then this thing can also be added to this part. See, normally what you get is you get an entire case study based on the requirements which are specified. We'll draw this,
Okay, sir.
right? Any doubts? No? Okay. So the next, I'll draw it here for my convenience, or let me mm, let me duplicate it. That would help you as well, and that would help me as well. Yeah, the only problem is I cannot erase it. Yeah, so this was about process view. Now let me talk about your development and physical view, both. Right, so let me use this color for physical view. Now, physical view will say that okay, this catalog is available on a public IP. It's available to the outside world. Right, rest background details is not required. Right, so my catalog is available on a public IP. It's on a separate machine, not input but IP. Then this circulation and the user registration is on a separate machine, and this payment can be on a separate machine or can be from the external agent as well. And this rest acquisition and journals are our internal matters. Keep it on a separate machine. Right. Keep it on a separate machine that is for our internal purposes. So this becomes a part of your physical view. We said na, here we'll talk about your communication medium, we'll talk about LAN, WAN, bus system, and other details as well, right? So all the physical setup will be a part of it. Then we have development view. Okay, by the way, any doubts in this, so that we can move to the next part as well. Any doubts in this?
No, sir.
Okay. So, in case of development view, what we will say is that let us develop these modules in our, let's say, company office, which is there in, let's say, Jaipur. Let us develop this module in our company office, which is there in Bangalore, and we can specify the team as well, right? That details we can give, and let us take a call on these where we can have our Delhi office taking care of this. A team sitting in our Delhi office will be taking care of this particular thing, right? So this becomes your development view. See, I've used a different pen in order to give you an idea. And next, last one is your plus one view. That is nothing but your use case view, which you have already thoroughly studied in case of your software engineering. So I'm skipping that part. But yes, that is there. Whenever I'll give you some assignment or maybe some questions or some case study on this particular thing, then you have to draw the plus one view as well. Right? That's how this entire thing should work. So basically, this 4 plus 1 view model is used with, success on several large projects, you can say, right? And definitely we can have some small local customizations and adjustments in the notations plus your terminologies. So basically, this model actually allowed various stakeholders to find what they want to know, and uh, what they want to know means about this software architecture. So your system engineer will approach it from your physical view, and then from the process view, your end users, your customers, your specialist will view from your logical view, your project manager and your software configuration staff can see it from your development view. So everyone is taken care of, everyone can have a view on it. They can go to several other notations, plus they can take another level of depth for this particular thing, and obviously they can have a much more detailed model. So this is basically, not every software architecture need this full 4 plus 1 view, right? In case of agile development, they will not be having this much amount of time. And some of the views can be, sometimes useless. And because let's say I have a small application, right? I don't need these many teams which are sitting in these many locations. A simple single office setup which is there in Jaipur city will come up with the entire application. So definitely I don't need to go for development view, right? And the entire setup will be running on a, let's say, cloud server or a simple single server, in-house server. Then once again, I don't need to go for your entire physical view. I can omit that. So this particular application gives this kind of flexibility as well, right? This particular application gives this kind of flexibility as well. Any doubts in this?
No, sir.
Okay. Okay. So as I said, it's not always that for every application you have to come up with this entire thing. It's like many times skip some of the parts, right? And then what we can have is that we can come up with a partial kind of thing. So we can tailor it, right? So uh, let's say in case of physical view, right, I'll omit some of the things, and if suppose there is like only one processor and only one process view is there, so then also I can customize it, and obviously the remaining part remains still useful in this case. So any doubts up till now? No. Okay. So let's say, let me give you a short assignment, right? Let's say I have a mismanagement application. So can you, which is definitely dealing with the payment from all sorts of users, and then we have, it's like you know we have certain uh, users who are on daily basis who are availing the facility, and then we have certain users who are on rarely having food. So then they have the entire payment systems. So can you come up with an application where I have to uh, come up with your uh, 4 plus 1 view architecture for this entire view?
So can you repeat what management system we have to draw for?
uh, I'm talking about mess management system.
Oh, okay, sir.
Yeah. Yeah, maybe you can have give a try, and we'll once again discuss. And maybe in the meantime, we can take some doubts if you have any. Any doubts? Any doubts?
No, sir.
Okay, fine, fine. Then we are good for today. Then we'll meet on Thursday. See you then. Bye bye.